G'day viewers, a bit on neutrinos today. Why we've got to go back to neutrinos is because they are the fundamental building blocks of the universe. They're the smallest known complete components that we can detect, and if we're right, they're probably the smallest and there is nothing smaller, except for possibly and maybe Gary's components, what he calls his force bits. Just a couple of things. Why I've chosen gravity bits instead of matter bits is because gravity's a force, and when you add them as gravity bits, they make matter. Gravity makes matter. It's not the other way around. And I've arrived at that conclusion because of the componentry that I've been able to build using Gary's bits. There's three different types. There's gravity, there's electric, and there's magnetic bits. Three different types. And three's the magic number. And we'll go through this a little bit later, but let's just get into the basics. We know very little about neutrinos, so we can only mathematically construct them using the components and theories and knowledge that we've already built up. Starring a cast of thousands, there's that many people that have built up this knowledge over the last few hundred years. Probably starting with Newton, Henry Cavendish, Benjamin Franklin. And while I'm just mentioning Benjamin Franklin, and this is, I understand why Gary doesn't like this and I don't like it, he said that the electron was negatively charged. He had one chance, he had a 50-50 thing to get it right, and he decided to choose negative polarity, when in fact the electron should be a positive polarity, and that is because it is a positive energy. And you'll always see electrons flowing from, they flow in a manner of negative to positive. But anyway, we can live with that. They call electrons negative, so all we've got to do is invert the charges on all the math and just invert the sign. So instead of being positive, we just call it negative. It still works. It's just a conceptual problem. It's much easier if you look at it in an inverted method. So there's three types of basic neutrinos, and then you've got their antineutrino. So that means there's 6 types of neutrino, but we'll just look at how 3 are formed. The other day I was drawing out Gary's bits and I thought, that you make a quark configuration with that, and it worked. But then I was thinking last night, no, that is it works, but I've got the wrong scale. I should have been looking at neutrinos. Because if you have two different gravity bits, a red one and a black one together, you get your basic neutrino type. If you get 2 red bits and a black bit, you get your second neutrino type. If you get 1 red bit and 2 black bits, there's your third neutrino type. Now they're all gravity bits. There's no electric bits, no magnetic bits in a neutrino, and that's why I love it. That's why I'm going back to neutrinos, to remove any unnecessary complications. And I won't show you how I got the antiparticles to these, but it was very interesting, and then it changed my whole concept, and it actually conformed to different shell structures and energy pressure layers, if you like. So this is the most I've ever come with neutrino physics, and now I can mathematically and physically describe a neutrino right down to the nth level. Now the thing about neutrinos is they're actually smaller than photons, and that is mind-blowing in itself. So neutrinos will travel faster through ice than light, and there's two possibilities. Is because of their extremely small size, and secondly is because they have no electric or magnetic component to worry about. They travel at nearly light speed, but you go and have a look at that. I think it's Ice Cube experiment in Antarctica, and they say that the neutrinos travel faster through ice than light does, and then I was able to work out why. They don't have the drag factor, so there's another little bit of evidence in the piece of our puzzle, and they do interact every now and again, but because they're so small, there's not too much interaction. But I've got some interesting pictures. It's probably, I don't know if I should really, yeah, I will. I'll show you. I'll show you the mathematically generated picture of a single photon, and I'll show you the hologram that they reconstructed from raw measurements of a photon, and this is pretty close to, I'll show you anyway. I'll just swing it round there. There's the one on the left is the reconstruction, the one on the right is their mathematical generation. Now if you look at the outermost blue patterns on the right hand image, they are actually, that's like the counter generation. There's the primary fields are the four fields in the centre. Two of those are electric and two are magnetic. They're in pairs. But the outer ones are the opposite fields. So the primary fields in their oscillation have induced into free space around the photon. They've induced these counter fields, a back EMF or counter magnetic field. So we'll go back. I'll show you what I came up with. That's my sketch, and let me explain it. That's your north. This is only a snapshot of a photon in time. This is like a cross section of a photon, and I'll tell you what that other picture doesn't tell you. That's your magnetic north pole. That's your magnetic south pole. Now these oscillate backwards and forwards, so they're actually spinning around while the photon is moving at the speed of light. And there's some real crazy stuff that happens inside a photon from my working out. Now these other two triangles, and like I said, this is a cross-sectional area. I believe these to be cones, and that's simply from reconstructing the electric and magnetic fields. These are cones, but if you slice a cone in half, you get a triangle pattern. Now there's your neutral zone right between the, if you look at the sine wave of the photon, that's the 0 point. Now I haven't drawn in the outer pieces out here. I haven't drawn in the counter fields because they are a product of the photon. They're not actually the photon, they're just the photon interacting in free space as it's travelling. And a lot of people will tell you that as the photon travels, it leaves a helical or double helix trace. Bullshit. Does not. And we get confused because we analyse the photon from this pattern here. And whilst that is correct as a indication of magnetic and electric fields within the photon as it's travelling, it's not actually what the photon is doing. It is just an electrical measurement. And my proposition is that these are rotating one way And this field here, that's your negative electric field, that's your positive electric field. North magnetic pole, south magnetic pole. Now, you can show this to any physicist. They probably won't get it for a start, but if they want to really study it, you'll find that I'm right, because I've drawn the actual moving field, and I'll tell you right now that the average field speed of the photon is the speed of light, but internal to the photon there are things moving faster than the speed of light. Now, I know you probably won't understand that, but it's all relative to the speed of light, that things travelling inside the photon's field can move, and they do move faster than light. That's all there is to it. But in the photon, there's no gravity bits, and there are the components in that photon. There are electric bits and magnetic bits, but there's no gravity bits. That's completely the opposite to a neutrino. Now, why am I talking about photons and neutrinos? They are related. They're totally related. Because if I can hit a neutrino with a high enough energy photon, and it's the right neutrino, say an electron neutrino, and that's not the simple neutrino, that's one comprised of three gravity bits. I'm not sure if it's the second or the third type, but it's one of those. It's one of the either type 2 or type 3. If I hit the neutrino with enough, with a gamma ray photon with the right energy, I will create an electron, and that's my proposition, and that's thanks to Gary's theory. Now, it's actually a reciprocal thing. If you collide a positron and an electron, you'll end up with two electron neutrinos, and you'll also end up with two gamma ray photons. Now, when you're talking about photons and antiphotons, it's a matter of perspective or relativity to the observer. In one direction you'll have a photon, and in the other direction you'll have the antiphoton. It doesn't make a difference. Photons are photons. You can combine them. If you combine two gamma ray photons, and yes, it is possible to collide two gamma ray photons. If you collide two of those with two electron neutrinos, and I think one would have to be, it's logically to assume that one would have to be an electron antineutrino, and the other one would have to be the electron neutrino, then you would end up with, you would actually reverse the mutual annihilation process, and you would end up with back to your original electron and positron pair. So that's what I've learned from mucking around with a few figures and facts and diagrams and drawings. Like I said, I've only just started this theory. I just started working with Gary's theory, and I misunderstood a few things, and I had to take it down. I had to take it down to a scale of quantum foam, where we're talking about 1 × 10⁻35 of a metre or such. I think you're really onto something, Gary, there, and I'll continue to work with this. And my point is, for a unified field theory to work, it must work over all scales. It must be applicable to everything in the universe, and it's changed my view of the universe dramatically. I'm combining ether, counter space, and everything all into the one term of space. It's and space isn't empty. From what I've learned now, is space is jam-packed. It's incredibly packed. Now, later on we'll go into talking about dark energy, dark electricity, dark matter. To me it's no longer dark. I'm over the moon. Using Gary's 3 fundamental force bits, it's opened up a whole new vision to me. A lot of the facts and from the old classical physics days still work, but they're just more easily understood on a quantum level with this sort of information. And just on a closing note, the slit experiment. I will construct a piece of apparatus. I've got everything in the shed, don't have to buy nothing. I've got lasers, I've got bits of wood, a couple of screws, power supplies. I'll put it all together and then I'll change the parameters of the actual slit. We'll keep the photon source the same, we'll use a red laser, we'll keep the target will be the same. Yeah, but all we will do is we'll keep we might do a couple of different measurements just for